Welcome to File System Interface. So this is another lecture for our operating system. So what is a file? So file and directory. So we have here the features. So a file system implementation of a file abstractions for a secondary storage. It is also implement the directory abstraction to organize the file logically. So sabi dito, this is a secondary storage. So it means that this is not our RAM like we talked about previously, the lecture for our virtual memory. What is the usage of file and directory? It is used for user to organize their data. It is used to permit data sharing among processes and users. It provides mechanism for protection. So if we remember, when we open a certain file, if we look for the setting of that file, the property of that file, we will see their sharing protections and then the name of the file. Okay, the term file system is a little bit confusing. So the component of OS that know how to do file stuff. Okay, so para siyang secretary that know how to organize folder, how to organize name, how to keep things properly. So our operating system is also called a manager. Okay, so it's set and file system is one of it. So a file system is a set of algorithm and techniques. The content on disk that describe a set of files. So on the disk system file, so we have the files in the directory. So this directory also pertain to the table component. So yung file, for example, a picture, so yun yung files natin. And the directory is where our file is located. Remember that a disk can be partitioned arbitrarily into a logically independent partition. Each partition can contain a file system. In this case, the partition is also or often called the volume. One can have multiple disks, each with arbitrary partition, each with a different file system on it. So, for example, in here, example of 2 disks and 3 file system. So, in here, partition A, so we have a file in the directory, partition B, a file in a directory, and partition C, a file in a directory. So, in here, considering that each of the partition can be formatted into different file formats. So, if you remember your flash drive or your hard disk, so you can have the FAT32 format, the NTFS. So, this is file system. So, for example, partition A is a FAT32 file system. This is NTFS, and this is FAT32. So, file system can exist in one disk or one hard drive, but we need to partition. So, ibig sabihin, lahat ng files natin dito will be in one file system format. All of this file will be in one file system format, and all of the file in here will be in one file system. Okay, partition, this one, these two. Okay, file and file type. So, a file is a data plus property or attribute. So, pag sinabi nating file, anong file yan? What is that file? Is it a music? Is it a doc files? A Excel file? So, a file. So, a file has its property and attributes. It has the content, it is the size, it has the owner, the last read and write time, the protection, etc. So, a file can also have a type. So, understood by the file system are regular file, logical link, and devices, or understood by the OS, executable, shared library, object file, text, binary, etc. Okay. So, yan yung pwede nating i-link or the things that we can link with a file. So, a file can be an executable. For example, it is a program, an executable code. So, it is an executable file. But in a regular file, it's just a raw file that will not execute, or just simply a notepad or a text file. So, in a window file types, is encoded into its name. So, for example, in Windows, we have .com, .exe, .bat. Some known to OS, some just known to application. Okay, some known to OS and to application. It means that a certain file can be known to OS. It means that the OS know what is the content of that file, and the OS can open that file. Or if it is only known to certain application, it is those files that you cannot open without downloading specific application. So, for example, you have a .docs, but then you don't have an MS Office or Microsoft Word Office that can open this .docs file. So, that file is only known to a certain application, and all other files that you cannot open because you need to download that specific application. Like, for example, if it is a zip, so you need to download for that WinZip if you to be able to extract that file. So that file is only known to application. In Mac OS X, each file is associated with a type and the name of the program that created it. So done by the create system call for all files. Allow for double check for reminder which program to use. So, iba naman yung file system ni Mac OS. In Linux, a file type is encoded only in its content. So, magic number first byte. So, ganyan yung atsura. So, this will look like. Some files have no types and file names are arbitrary. Okay, good question. Should OS know about the structure of a file? The more different structure the OS know about, the more help it can provide application that uses particular file type. But then, the more complicated the OS code is, and it may be too restrictive, etc. Assume all binary file are executable. So, maganda ba? So, in Tagalog, so, maganda ba na dapat alam ni OS ang lahat ng file types? So, but then, if OS will know all the file types, it will requires a lot of coding for the OS developer. Okay, modern OSs support very few file structure. File are sequenced by byte and OS doesn't know about, but have meaning to the application. Okay, kasi nga siya, only known to application. Okay, OS can expect a certain directory structure defining an application. And internal file structure, we've seen that this provide the OS with the block of abstraction. So, we don't really designate where to put the specific file on the location of our hard disk. So, for example, this is our hard disk. This is our file. So, OS now will designate into what part of the hard disk will the OS save our file. So, that is what we call the abstraction. So, we let our operating system do the saving of the file, and we don't know where a specific sector or location of the hard disk our file is located, but we just know the name. Each file is stored in a number of blocks. Okay, so it is stored into internal fragmentation. Okay, file operation. A file is an abstraction, right? It's an abstract data type. As such, when we say abstract again, so abstract can mean a lot of things. Yan, abstract. So as such the OS defines several file operation, basic operation. Our file have this operation. Okay, file operation, of course, the creation of the file, the writing and reading of file, and then repositioning the current file position pointer. So it is called Acyclic. Appending at the end of the file. So when we add to a certain file, truncate down to 0 size, deleting and renaming. So that is the operation. So we have CWRATDR. CRWATDR. Okay. Open files. So the OS requires the processes to open and close a file. Otherwise, OS could spend its time searching directories for file name for each file operation. So that's why when we search for a certain file, we can search something, a word inside that file. And then the OS will look for it inside our files. So after an open, the OS copies the file name, the file entry attribute into an open file table that is kept in our RAM in the kernel. So the OS keep two kind of open file table. So one table per process, one global table for all process. So the processes specify which files the operation is on by giving an index in its local table. So the famous file descriptor in Linux. So ito po is for Linux. The OS keep track of the reference count for each open file in the global tables. Incremented each time the process opened the file and decremented each time the processes closed the file. Okay, so an example here. This is, for example, for file A, the location of file on the disk, and block number of the first block, and the number of block, and then the size of it. This is the location of file on the disk. The attribute of the file can have permission, read, write, or only read, not write, the owner, time creation, and date of last modification. This is kept on disk, but for now we take the logical view of it. Let us say it is in the OS or in the file system. So this is the disk, this is the OS. So when the file is read from this disk, it will get a copy of the file to our RAM, and then from our RAM it will now be read, of course, by our CPU. Then how do I spell CPU? Okay, we know that the only memory that our operating system or our CPU communicate with is our RAM. So to be able to read a file, you need to copy the file to our RAM. Okay, so let's have some example. Okay, so we said that there is the file table. So when we run a process, we'll get a copy of that file. So this is the file, and then this is our RAM wherein hold by our operating system. So we have process 2. Sabi niya dito, process 2 needs to open file 1. So process 2 table will go to the next table, process 2, and then locate for file A. Okay, so that is for example for process. So let's say process 1, open file A. Yan, open file A. So i-delete natin. Okay, process 1. Process 1, we have A and C. So process 1, makita natin naka-increment siya because there are two process looking for file A. And then we have file C. Okay, one is looking for file C and then relocating file location of file C. So this is the process table and this is the global table. Okay, next. So it's the same example but now we are on file B. So kanina file A, ngayon file B. So on file B, so we have the process 2 table locating for file B. Okay, let's have an incremental value of 1 and then locating file B. So this is how our process table and global table look for our file. Okay, file lock. What is a file lock? So bad things may happen when multiple processes refer to the same file, just like when thread refer to the same memory. Okay, so our file location is our resources. So remember that our OS is a resource allocator. Okay, so a file lock can be acquired for a full file or for portion of the file. So file lock pwede sa full file or the portion. The OS may require mandatory locking of some files. Example, for writing a log file that many systems can write to, typical application have to implement their own locking, and the sources there can be deadlocks and all of the missedness of the thread synchronization. Okay, so without file locking, it can cause two deadlocks. So for example, one is writing a logs on a file and other program that also locate to the same file, which is the file log, can cause a problem or error. That's why while it is being used sa writing, the file is required to lock. Level and two-level scheme. Each directory can contain files or directories of the files, differentiated internally by a bit set of 0 for file and 1 for directory. Each process has a current directory. So you have the relative path and the absolute path. So we have the file translation 1, 2, and 3. So open the file, know where that is on the disk, search for 1 and then get location, then open 1, search for 2, get location, and open 2, search for 3 and get location 3. So this is how it happens. This is a file path name translation. So this one here, the file knows where it is on the disk. So the file open, we have folder 1, location 1, and then from location 1 there is a location 2, and from location 2 there is a location 3. So for example, you have a file. For example, you have the disk C. This is the path translation. Let's say disk C. Actually, if I'm not mistaken. And then you have document. And then inside that document, let's say my folder. Okay. So the OS spend a lot of time walking directory path. Another reason why one separate open From read and write, the OS attempt to cache common path prefix. But what we have in modern system is actually more complicated. So this is the Acyclic graph directory. So the file directories can be shared by more directories. So you see that, ayan. So mayroong shared. And then we have the list. And then this is our file. And then this count file. So the hard link is created in the directory to point to or refer to another file or directory. The file system keep track of references count for each file. Okay, so this is not really we cannot really see this for MS Office or Windows operating system, but it's very much common for or used for our Linux file system. Okay, let's discuss about the file system mounting. So when we said mounting, it is when we plug, okay, when we flag a storage in Linux. In Linux, our hard disk can be plugged or unplugged. So that's a certain partition of our hard disk. So when you want to access it, you need to mount. Okay, each file system is mounted at specific location or mount point, typically seen as empty directory. When given a mount point, a volume file system type, the OS asks the device driver to read the device directory. Check the volume. If it does contain a valid file system, make one of the new file system that specified mount point. macOS, all volumes are mounted in the volume or directory. Okay, in Unix, volume can be mounted anywhere. In Windows, volume are identified into A, B, C, D. That's why when you open your flash drive, it is letter F, letter G, letter H. Yan. On Linux, the mount command lists are mounts volume. So, protection, the files provide controls access. General approach, the access control list or ACLS. So, each file or directory keep a list of user and all allowed access for each user. So, that is what you call protection. Problem, ACL can be very large. The solution is consider only a few group of user and only a few possible action. So when we say user, please refer to when you log in, okay, in your computer and you are a user. So whatever is the designated name of the user, so that name is the only one who can access the certain file. So this is access control. Okay, so that is for our file system interface, files, and directories.